We are taking R.D. Sharma Solutions, Class 10 Maths, Chapter 16, Exercise 16.2. So the first question is, there is a tent here and we have to find out the area of the canvas when there are two parts of this object, or you can say this tent. First is this conical one, and then we have this cylindrical one, this conical one and this cylindrical one. So what all are given is, let us take the things which are given is, this is radius of the cylinder part. This is the radius of the cylinder part, which is 12 meter. So this is the radius of the cylindrical part, and this is also the radius of the conical part. And the height of the conical part is given 5 meter, and the height of the cylindrical part is given as 11 meter. Now we have this as 5 and this one as 12. So in order to find out the curved surface area, we need to find out the slant height. So if this is 5, this is 12, what this will be? 12 square plus 5 square. So this is going to be 13. Okay, this is going to be 144 plus 25, and that is going to be under root of this 169, and then it is going to be 13. So L is 13. Now the curved surface area for the cone will be pi into r into L. Pi into r into L. So pi is pi, we know the value. R we are going to use as 12, and L, which is the slant height, is going to be 13. Now what is the curved surface area of this cylinder? This is going to be 2 pi RH. 2 pi RH. So 2 into pi into r, radius 12, and height is given as 11. So when you combine this, or when you add this, you are going to get 13 and 13, 20. And this is area of the canvas required for the tent, which is 1320 meters square. Now consider a rocket. So it's a rocket. Suppose the rocket is in the form of a circular cylinder. So this is a circular cylinder, and it is closed at the lower end, while the cone, this is a cone of the same radius attached to its top. So the cylindrical portion of the rocket has radius 2.5 meters. So this is 2.5 meter from here to here. So the cone will also have the radius as 2.5 meter. And the height of the cylindrical portion of rocket is 21 meters. So this height is 21 meter. And the conical portion of the rocket has a slant height. So this is a slant height. This height is given as 8 meter. So we have to calculate the total surface area of the rocket and also find the volume of the rocket. So total surface area and volume. So we have the radiuses, and then we need to find out the height also, because this height is important. Otherwise we will not be able to find out the volume. So because the slant height is given, we'll start with the total surface area. What is the surface area? This surface area of the cone, which is pi into r into L. Pi is 22 by 7, r is the 2.5, which is this one. Radius is, both of them have same. And then L is the slant height. It is 62.85. Now what is the surface area of the cylinder? Because this is covered by cone, so we don't take this one, but we'll take the curved surface area along with this base. So 2 pi RH and pi r square. So we have to add this. So radius is 2.5 and height is given as 21, and also the radius will take it as 2.5. So this is going to come as 349.64. Now in order to find out the total surface area of the whole object, we just have to add these two. So that means this one and this one has to be added. So this comes to be 412.69. So the total surface area of the cone is 412.69. Now the slant height of the cone, because let me take this triangle. This one is 8. This one is 2.5. So the height will be like this. So height of the cone will be 8 square minus 2.5 whole square. So 8 square minus 2.5 whole square, that will be 7.59. What is the volume of this cone? 1 by 3 pi r square h. R we know 2.5, height we just found out. So just multiply and 49.10 will come. And coming to the volume of the cylinder, it is pi r square h. Pi into r square into h. So pi, radius is 2.5 and height of this cylinder will be 21. Now these two have to be added. These two have to be added in order to find out the total volume of the rocket, and this is going to come as 461.6 meter cube. Take a tent structure is envisioned being cylindrical in shape with the height 77 decimeter and is being surmounted by a cone at the top having height 44 decimeter. The diameter of the cylinder is 36 meter. Find the curved surface area of the tent. So here what we will do, see, I'll just show you and then I'll come back to this one. Okay, now take a tent structure, cylindrical in shape, surmounted by a cone. So same thing is going on. This type. So now what is given? Height of the tent. Height of the tent is given as 77. So from here to here it is 77. Then height of the surmounted cone is 44. So this is 44. And what is this? What is this height? It is 77 minus 44. That is, this is going to be 33. Right? 77 minus 44 is 33. So now the height of the cylindrical portion we found out using 77 minus 34, that is 33 decimeter. And we know that in order to convert the decimeter into meter, we just have to divide it by 10. Right? So it will be this 3.3 decimeter, and this will be 4.4, this will be 7.7. Now, coming to the diameter of the cylinder, which is D, which is given here. The diameter of the cylinder is given, so the radius will be 36 by 2 and it will be 18. So it will be 36 by 2, that is 18. And what is the slant height of the cone? Because it is 18 and this is 4.4. Okay, this is 4.4 because this was the height of the cylindrical portion, so height of the cone. Okay, we have to find out. So this will be not 3.3 whole square, but it will be 4.4 whole square. Okay, this is 4.4. Height of the surmounted cone. So we are interested in the slant height of the cone. So 4.4 square will be there. And this L will come as 18.3. If you just let me show you the calculation. So this 18 square will be 18 into 18 is 324 plus, and then we have 4.4 into 4.4, and this is going to be 343.36. okay, and same thing, and just take the root of this one. When we take the root of this one, it is going to be 18.3. This is just 4.4. Now the slant height is also known. Coming to the curved surface area of the cylinder, it is going to be, cylinder will be 2 pi RH. We know 2 pi, we know the radius, and h height for the, see, height is this one for the cylinder. So it is going to be 3.3. Just a minute changes there. Then curved surface area of the cone is pi into r into L. Pi into r, 18 into L, we just found out 18.3. And you just need to, this is 3.3. This is 3.3, right? Cylinder. Now just add these, you'll get 1532.46 meter square total surface area. You have to add 2 pi RH with pi RH. A toy is in the form of a cone surmounted by a hemisphere. So this is a cone. This is a cone surmounted by a hemisphere. So the diameter of the base and the height of the cone are 6 cm and 4 cm. The diameter of this base and the height of the cone is 6 and 4 cm. Determine the surface area of the toy. So now we have this as 3 and this is 4. So what will be the slant height? This height, it will be 3 square plus 4 square under root for this conical part, and this is going to be 25, under root 25, and it is going to be 5. So this phi is the slant height, phi is the slant height of this cone, right? Now, we know that the curved surface area of the cone is pi into r into L, this one, pi into r into L. We just found out this to be 5, and radius we already know it is 3 for both of these toy objects or parts. Now, curved surface area of the hemisphere, this hemisphere, actually the hemisphere has a curved surface area, total surface area. A hemisphere has is 4 pi r square. So a sphere, and a hemisphere will have 2 pi r square. So 2 pi, again 3 square. So it will come as 56.23. This will come as 47.1. So you just have to add these two, and this is going to be 103.62 centimeters square. This is the curved surface area of the toy. A solid is in the form of a right circular cylinder, if you see here, with a hemisphere. This is a hemisphere at the one end, and there is a cone at the other end. Hemisphere and cone at the other end. The radius of the common base is 3.5 meter. This is 3.5, this is 3.5. So the radius for all these three different parts of this, you can say toy or an object, these are all same. Radius is same for everything, every three parts here. So R is 3.5, and the height of the cylinder and the conical portion are 10 and 6. So height of the cylinder is this much, 10, and then 6 is the conical portion. So 6 is this one. And we have to find out the total surface area. So total surface area, let us start with the cone part. So this is 6 and this is 2.5. So 6 square plus 3.5, sorry, 3.5. So this is 3.5. So 6 square plus 3.5 whole square. If you take this triangle, this is 6 square, this is 3.5 whole square. This slant height will come and it will be under root. So it will be 6.94. And now the curved surface area of the cylindrical part. Cylindrical part is what? 2 pi RH. R we already know, height is already given 10. So 2 pi RH, it is going to come as 220. The curved surface area of the cone is pi RL. So L we just found out. Radius is same for each of these. So pi into 3.5 into 6.94, it will come as 76.34. Now coming to this hemisphere part, it will be 2 pi R square. The curved surface area. Radius is 3.5. So it is going to come as 77 centimeters square. So the total surface area of the solid will be this one, S1 plus S2 plus S3, and it is going to be 373.34 centimeters square. A toy is in the shape of a right circular cylinder with the hemisphere at one end and cone at the other end. So if I can show you the diagram, I have to make it. So let me make the diagram first, then we may be able to understand it better. A toy is in the shape of a right circular cylinder with a hemisphere on one end and cone on the other. So there is a cone, there is a cylinder, and this is three parts actually. So we have a cone, we have a hemisphere, and we have a right circular cylinder. And the radius and height of the cylindrical part are 5 and 13. So radius is 5, so 5 will be radius for each of these. And what is the height? It is 13. The radii of the hemispherical and conical parts, they are same because they are entirely fixed on it. Find the surface area of this if the total height of the toy is 30 centimeter. So total height is 30 centimeter. So this is 13. What is the radius here? This portion. And this is going to be the radius here. So it will be 5 also. This will be 5. So 5 is there, 13 is there. What will be the height of the cone? It will be 30 minus 15 minus 5. 30 minus 18 actually. It is going to be 12. So the height of the conical part is 12. Now coming to the curved surface area of the cylinder, it is going to be 2 pi RH. So 2 pi, radius is given, height is given. 2 pi RH, it is going to be 408.2. Now curved surface area of the cone, it will be pi into R into L. Pi into R into L. So what will be the L? This is 12 square, this is 12 and this is 5. We just found out. 12 and 5. So this will be 12 square plus 5 square whole square. This one, it is going to come as 13. So pi into 6 into L, L will be, say I just told you the height we found out to be 12. And then this L will be under root R square plus H square, that is 5 square plus 12 square, 25 plus 144, it is going to be 169 under root, it is going to be 13. So we just have to write here 13, pi into 5 into 13. Now curved surface area of the hemisphere is 2 pi R square. Radius is same for all these three, it will be 5 only. This will be 5, so it will be 2 pi R square. And now you have to add these three, S1 plus S2 plus S3. So this one and the previous one we found, we just have to add it. It is going to be 769.3 centimeters square. Consider a cylindrical tub having a radius of 5 centimeter and the length is 9.8 centimeter. It is full of water. The solid is in the form of a right circular cone mounted on a hemisphere which is immersed in this tub. If the radius of the hemisphere is 3.5 centimeter and the height of the cone outside the hemisphere is 5 centimeter, find the volume of water left in the tub. So we have a cylindrical tub here, like this. This is a cylindrical tub having a radius. So this radius is 5, length is given as 9.8. A solid is in the form of a right circular cone mounted on a hemisphere. So there is like this. So it is being immersed now in the water. And the radius of the hemisphere, this radius is 3.5. This is 3.5. And the height of the cone outside the hemisphere, which is this one, is 5. This is 5. Find the volume of the water left in the tub. So when this object or this is placed in this cylinder, the water will come out, and the water that will come out will be equal to the volume of the immersed or submerged this object of cone and hemisphere. So what we will do, we'll find out these two combined area, and then the cylinder area. Cylinder will have some water. So the cylinder water, when it is subtracted from this volume, which is the volume of this object, that will be the volume of the water being left. I hope you got the idea. We'll find out the volume of this one, and the combined one, we'll subtract that, then that will be the volume which is water, because this has gone inside, water has come out. So the water which has come out is actually equal to the volume of this one. So we just subtract this volume with this one. Now here various things are given. Let R be the radius and H be the height of the cylindrical tub. So R is 5 and H is 9.8. This is 5, this is 9.8. So volume is pi into this volume is pi into R into, this is cylindrical part, pi R square into H. So pi into 5 into 5 into 9.8, pi R square is 770. Now for the hemisphere it will be and cone. Hemisphere is 2 by 3 pi R cube. So we know the R 3.5, 2 by 3 pi R cube. And we know the volume of the cone, which is 1 by 3 pi R square H. R is 3.5, height is already given 5. So this is 64.16. So what we will do, we'll add these two and subtract the addition from here. So 770 minus 89.83 minus 64.16, and this is the volume of water which will be left in this cylinder, and this is going to come as 616 centimeter cube. Now a circus tent has a cylindrical shape surmounted by a conical roof. The radius of the cylindrical base is 20 centimeter. The height of the cylindrical and the conical portion is this much, 4.2 and 2.1. Find the volume of the circus tent. So here we have a circus tent, we have a conical shape, and this is a cylindrical shape like this. Now the radius of the cylindrical base is 20. So this is 20, this is also 20. And the height of the conical portion, cylindrical and conical portion, so cylindrical portion is 4.2 and conical portion is 2.1. This is 2.1 and this is 4.2. Find the volume of the circus tent. So the parameters given here are like this. Volume of the cylindrical portion will be pi R square H. So it will be pi R square H. And this we can compute because R we know 20, height is 4.2. So it is going to come as 5280. And what is the conical part? It will be 1 by 3 pi R square H. 1 by 3 pi into R, R will be 20 square, height will be 22.1. And this is going to be 880. So you just have to add these two to find out the volume of this circular tent. A petrol tank is a cylinder of base 21 and length is 18. This is 18. And this is fitted with conical ends. So this is one conical end, this is another conical end. Each of X is 9 centimeters. Each of them is having a height of 9 centimeters. Determine the capacity of the tank. So what we will do, we'll find out the volume of this one and these two and add them. Okay. So what all are given? See, this radius is because the diameter of the base is 21. Radius will be 21 by 2. So the radius will be 11.5. Radius of these two will be 11.5. And length is 18 centimeters, so length is 18 centimeters. And determine the capacity. So what is the volume of the conical part? It is going to be 1 by 3 pi R square H plus 1 by 3 pi R square H. Actually, it is 1 by 3 pi R square H into 2. So 1 by 3 pi and R is 11.5 and height is this part is 9. So 9. Okay, we just took one of these and multiplied this with 2. So this is going to be the volume of the conical part. When come to the cylindrical part, it will be pi R square H. So pi R is, this is 11.5 and height is this 18. So pi R square H, it is going to be 7481.57. And we just have to add these two and this is going to be 9975.41 centimeter cube. This is the total capacity of the volume of the tank. So this is all about this part, but we are having few more parts of this. We'll be taking it shortly. Till then, thank you so much. Take care of yourself.